Hello,
Someone's
hello.
just commented saying, "Is this discussion technically a nerd snipe?" And I think that's absolutely true. Sorry, hi there, Poornima.
Hi, Hi, Martin.
Are you doing well today?
Yes, as well as I can be. It's school holidays here, so I've got a couple of days off, and I get to do fun activities like this too, presenting at a virtual event.
Perfect. Yeah, actually, also looking very much forward to seeing all the differences between gRPC, GraphQL, REST, and all of that. So definitely a good topic to bring here.
Absolutely.
All right. Without further ado, I think we can just bring up your slides and give you the stage, and then you can kick it all off.
Yeah, sure. Thank you very much. Thank you, the team at JetBrains, for having me as a speaker today. I am really excited to be a part of the event and to talk to you about REST, GraphQL, and gRPC, and a comparison between the three API paradigms. A little bit about myself. My name is Poornima Nayar. I'm a freelance .NET developer, and I'm based in Berkshire, UK. I'm a Microsoft MVP for developer technologies, and a lot of my daily work involves work around Umbraco CMS, which is a .NET-based open source CMS, and I have been their MVP for the past 4 years. Non-work me, I'm a mother. I spend a lot of time with my kiddo, as you have just heard about my school holidays. I spend a lot of time reading. That is my way to unwind myself at the end of the day. And I'm also a student of Carnatic music, which is a passion which I have kept alive with me for some time now. And that's my Twitter handle, should you wish to connect with me. My topic today, which is the comparison between REST, gRPC, and GraphQL, has been a big point of debate among developers and has been a point for Twitter wars as well. But that's not the approach that I'm going to take today. It's not going to be a debate. It's not about what is the best API paradigm out there. What I plan to do is compare and learn about these three API paradigms. I do not work with production gRPC or GraphQL, so I am not the best person to say what is the best, but we can always learn and we can always compare so that you can take away something from my talk today and then use that for your requirements going ahead. We have an API, we have something to compare, so we need a common data context. I'm not going to be building the APIs today. That will take a lot of time over a talk, but we do have a common data context to compare, or we need a common data context to compare, which I am using a very simple user database for. Name, title, description, that is it. A very, very simple user database. So we will understand the three API paradigms using the CRUD operations against this user database. From there, we can then think about what if we develop this simple user database to a fictitious social media platforms with each user having comments or likes or stories of their own, and how the API might look like in that instance. We will start with gRPC today. And gRPC is a modern, open source, high-performance remote procedure call framework. It is a flavor of an RPC framework. And the definition of RPC framework as per Wikipedia goes like this. It's a very long definition, but I'll try to break it down once I go through this. A remote procedure call is when a computer program causes a procedure to execute in the address space, which is coded as if it were a normal procedure call without the programmer explicitly coding the details for the remote interaction. So there are a few things that, if we pick out from this definition, will make things easier for us. The first one is procedure. That term appears quite often. So remote procedure call is all about procedures. Secondly, we have a computer program which causes a procedure to execute in another address space. So there is something executing in an address space. But what happens is I, as a developer, have a client program. I invoke a function in my client program. It looks like a normal local function call, but actually that function call jumps the network and executes in another address space. So there is that location transparency. Even though I'm invoking a procedure locally, it gets executed somewhere else. So that is remote procedure call. Now, remote procedure call is not something that is new out there. It's been there since around late 1970s, 1980s, and there's been various implementations of remote procedure calls over the years across various programming languages. WCF, if you're familiar with that, is one of the remote procedure call frameworks that we've had in the past with .NET Framework. So the star of the show with RPC framework or gRPC is procedure. You call a function on another server as though it was a local function. That is the essence of any remote procedure call. Procedures can also be called function call or subroutine calls or even RPCs. Let's briefly understand how the information flows in a gRPC or an RPC framework. We have client-server architecture. The client functions calls a client stub. A client stub is like a representative of the actual server function. The client stub is also responsible for packing the parameters through a process called marshalling, and it forwards that call to the RPC runtime on the client. That call is then forwarded to the RPC runtime on the server, where you have a server stub, which unpacks the parameters using unmarshalling and then calls the server functions. And this is where your call actually gets executed. And once the call is executed, I get the response back to my client functions exactly the way it went into the server. So this is how information flows in an RPC framework, and gRPC is no different. And talking about gRPC in particular, this is Google's implementation of RPC. It was called Project Stubby initially and was made open source and called gRPC in March 2015. And ever since we had .NET Core 3.0, we have official support for gRPC in .NET. And talking about the support further, we had WCF in the past in .NET Framework, but when we got into .NET Core, .NET 5, .NET 6, and ahead, we don't have official support for WCF, or we have very minimal support for WCF in the .NET realm. Of course, we have the core WCF, which is a community project to support WCF in the .NET realm. But if you are looking for something which is more officially supported by Microsoft in the .NET realm, gRPC should be your favored framework for RPC or message-based calls in .NET. gRPC favors contract-based API development, and it is designed for HTTP2 and beyond, which means that all the nice functionalities or features of HTTP2, like streaming and multiplexing, gRPC takes full advantage of that. And furthermore, we also have support for all major programming languages with gRPC. So if you're considering a polyglot system and in your requirement you have message-based calls or RPC calls, then gRPC is the framework that you need to be looking at. One of the technical terms that we need to understand with gRPC is protocol buffers. This is the interface definition language as well as message exchange format. And it is Google's open source mechanism to serialize structured data. Now, protocol buffers is not something limited to gRPC alone. All of Google Cloud uses that. If you have worked with Google Home devices in the past, you would have come across this term. Not only that, you can actually use protocol buffers as the mechanism to serialize your data in a normal web API as well. That is also possible because it's a mechanism to serialize data. But protocol buffers are language neutral, platform neutral, and extensible. It is incredibly smart about versioning because it's forward as well as backward compatible. And protocol buffers are transmitted in binary format. So with protocol buffers, which are also your message exchange format, each message looks like this. You have the message keyword followed by the name of your message, and each message has a series or set of fields or key value pairs called as fields. And each field has a data type, it has got a name, and it's got a unique sequence number as well. It need not be sequential in the sense 0, 1, 2, 3, and so on and so forth, but it has to be unique. Each field must have a number. There are two things about protocol buffers which stands out when in comparison to JSON. First one is that with protocol buffers, messages are always transmitted in binary format, which keeps their size really small and gives gRPC the faster performance that it needs to as well. Secondly, in JSON, we have the value of a field serialized against the name of the field. However, in protocol buffers, the value of the field is serialized against the unique sequence number that we see here. This is another reason why protocol buffers are smaller in size as well. So this name is probably a developer-only thing, but this number is actually what matters when it comes to kind of transmitting the data between the client and the server and client and so on. So these are the two main differences between JSON and protocol buffers, like out of the box. There's a whole scene of encoding that comes behind protocol buffer encoding as well. It's a very good read. Google Docs or the Google official documentation on protocol buffers is a very, very, very good read if you want to understand more about protocol buffers. Now, where are all these specified? All these are specified in proto files, which are files with .proto extension. So these files specify the contract of the API, and you also have the definition of the gRPC service in your proto file. So if you take a single proto file, that would be the contract of that particular API, and it would have a single gRPC service definition. So this is actually as a best practice. So if you have a proto file, you have a single service, and that single service can have as many procedures as you might need for your API. And you also have the messages that are sent between the client and the server in your proto file. So looking at how a proto file looks like, this is what I've got from the out-of-the-box template for gRPC projects. First, you have your syntax, which is the proto3. This is the syntax for this proto file or the protocol buffer. Then you have the C# namespace. So the option keyword is a protocol buffer keyword, which can be used to introduce changes at scope level. So this is introducing something at the global level. And C# namespace is like a C# specific option. And underneath the hood, every proto file gives rise to some code behind the scenes. So with this option, I'm saying that whatever code you generate, that needs to be put in the namespace that I'm telling here, which is grpc.basic. Then you have the package keyword, which is the namespace of the protocol buffer messages itself. So you can often have, or you might have, you might have services which are similar or might have the same name. You might have for any reason. So if you want to keep your protocol buffers in separate namespaces, the package keyword can help here. And this package keyword is also the starting point of versioning in gRPC. So if you go into the MS Docs and have a look at the versioning, this package keyword is of great importance there. Then you have your service definition. So in my case, it's the greeter service that I have. It's the out-of-the-box template that I'm using here. Then you have your RPC definitions. I only have a single RPC here called the say hello, but you can have as many as you want. Each RPC accepts a single input request, like the hello request that I have, and returns a single message as well. You cannot have multiple inputs like hello request 1, hello request 2, and so on. It needs to be a single object with multiple fields. So it is encapsulated in a single message. And then, of course, you have your messages, the input and output messages. You can list all of the messages that you have across your RPC definitions in your proto files. Now, when the MS build task kicks in, this proto file gives rise to code behind the scenes, which can be found in your OBJ folder. And what happens behind the scene is, on the server side, this service goes and creates an abstract class with the naming convention, the name of the service, dot name of the service, followed by the word base. So my name, the service name here is greeter for me. So the class that gets generated would be greeter.greeterBase. It's an abstract class. And each of the RPC definitions gives rise to a virtual method in that abstract class. So if I want to give my own implementation for this RPC method, what I would do is create my own class, inherit from the abstract class, and override the virtual method and give it my own implementation. That is how gRPC works. You don't have to worry about the input and output messages because they get converted into C# classes, plain POCOs behind the scenes. And by because of the tooling that we have with gRPC, that is the gRPC.tools NuGet package, which wraps the Proto-C compiler, which is responsible for generating all this code, that gives rise to code, or C# code, which follows all the best practices that Microsoft has laid out with regards to C# coding. So that's also taken care of. Now, this is on the server side. To talk to my gRPC service, I need a strongly typed client as well. So on the client side, the service gives rise to a service class, which again follows the naming convention, the service name dot service name followed by the word client. And I have my message stubs as well. So for each RPC definition in the service, I have a stub method as well. And this stub method, which is what I would be invoking from my client. And I have the POCOs for my request and reply messages as well. Now, how does the code generation get controlled? That is controlled from your CS proj using the protobuf tag that can be found in your CS proj. So having the presence of protobuf is an indication that it needs to treat this as a proto file and act upon it and generate code behind the scenes. Now, the kind of code, server or client code that gets generated is controlled by the gRPC services attribute. Currently, it is set to server in this example, so which means that the server-side code gets generated. If it is the client, you can set it to client. By default, it is both. If I omit out the gRPC services attribute, that is again considered as a both, and both server-side as well as client-side code gets generated. And if you set it to none, that is also possible. But as you can see, the sharing of the protobuf or the proto file is of key here. How you share it is up to you. Maybe all your clients are internal C# or .NET-based clients in which you can share it using a NuGet package. If you are looking at an API which is more public, then what you can do is create artifacts using your build pipelines, but somehow we need to publish that proto file so that clients in other languages like Go or Node can get hold of the proto file, and the compiler, which is a Proto-C compiler, has the understanding of the language and it creates the corresponding code for you in that language. So the sharing of the proto file is of key here. Now, going back to my data context, which is the user data context, this is how a CRUD operation would look like. So you have your proto file. I have stripped it down for the sake of grabbing a proper screenshot. I would have my user service, and I would have each of those as my RPCs. If I want to get a list of users, I would have get users. I can get a particular user if I want by their ID. I can create a user, I can update a user or delete a user. And each method would have its own request and reply models as well. And what happens behind the scenes is gRPC is a middleware at the end of the day. It works out a path to the RPC method that you're trying to invoke from your client. It normally does an HTTP2 post to your base URL, which is what you have here. And then the URL that it works out goes like so. So that is your base URL slash the package name. In this case would be user dot the service name. In this case, again, would be user slash the RPC name. So if I'm trying to invoke the get users method to get a list of users, it would be an HTTP2 post to the base URL slash user dot user slash get users. So depending upon the package name that I have here, this URL can change as well, which actually provides the basis of versioning in gRPC. So as you can see, it's very action-oriented. So now if you want to extend that user data context or extend my API to have to get the stories that a user posts or get the comments for a story or the latest activity for a user, all of that can be done by having corresponding action. So it is very action-oriented. Get me this, get me that, do this, do that. It is very action-oriented. But this is how you would do it in gRPC or any RPC framework for that matter. gRPC also has various methods. Till now, we have been dealing with unary, which is a single input from the server, so from the client, and the server sends a single response back. Then you have server streaming, where the client sends a single request into the server, which acts as a trigger for the server to open up streaming, and the server then starts to stream data from the server to the client. You have the opposite of that as well. That is client streaming, in which the client streams information to the server. And once the streaming is done from the client, the server processes the information and then sends a single response back to the client. And then you have bidirectional streaming, where the client streams as well as the server streams. You can have complex scenarios like reading happening as well as streaming happening from the server. You can also have client streaming, and once the client streaming is done with, the server can then stream back. Complex scenarios are possible. And all this streaming is based upon the HTTP2 features of request multiplexing and streaming, and the order of data or the order of processing is guaranteed as well. This probably has a stateful aspect to it, because streaming is all about having a request and then keeping that request open for a long period of time till the streaming is done with. So this is actually relying on probably more stateful aspects of HTTP2. You can also have request headers, you can have response headers. You can also have response trailers, which is a feature in HTTP2. Well, not exactly. I have read somewhere that HTTP1 also had trailers, but it is more prominent in HTTP2 because we have all the streaming functionality in HTTP2. And there's a difference between response headers and response trailers. Response headers are sent alongside the response, and it actually contains more generic information about the call itself. But if you are looking at more data about the call to be sent back to the client, you need to use response trailers. So if you have server streaming or bidirectional streaming or client streaming, you can send back information like how many packets of information you have processed, whether there was an error in streaming, and if so, how many packets processed before the error happened, what is the cause of error. All of that can be sent in response trailers. And response trailers are served after the response is complete. So you have your response headers, data, followed by response trailers at the very end. And talking about the pros and cons of gRPC, we have lightweight messages with gRPC. We have high performance. We have built-in code generation because of the Proto-C compiler. And we have streaming options relying on the HTTP2 features. And because of lightweight messages, we have reduced network usage with protocol buffers. I think there is at least a 30 to 40% difference between JSON and protocol buffers, the equivalent JSON and protocol buffers. And of course, gRPC is scalable. But gRPC is a contract-based API, so there could be tight coupling between client and server. But gRPC is incredibly smart about versioning, and with a little bit of love and care right from the beginning, you can have a fully maintainable and versionable API with gRPC, making sure that your service is all forward as well as backward compatible with the clients. Because it relies on HTTP2, we still have limited browser support with gRPC. Your proto files are your best method of discovering gRPC services. So you need to have some kind of documentation in place to make sure that developers at the receiving end know what they are trying to do or what they need to be doing with your service. And of course, it is not human readable. gRPC or any RPC is for computers to understand. It's for point-to-point communication, which means that it is in binary format. It's not human readable. And finally, the key feature of gRPC can go against itself because it can result in a function explosion. You can easily have a service with like hundreds and hundreds of RPC if you're not careful about it. And that brings us to REST API, which is probably the most successful, the most widely adopted API pattern. But having said that, it is also the most used, overused, and even abused API paradigm, because even when we serve JSON over HTTP, that is REST. That is consciously or unconsciously REST for us. You invoke a method, just like we did in gRPC, over HTTP, that is also REST for us. But there are some standout features for REST, which we will talk about in this session. REST stands for Representational State Transfer, and it was first presented by Roy Fielding in 2000 in his famous dissertation. Unlike gRPC or GraphQL, this API pattern is more of an architectural style for distributed hypermedia systems. It is just guidelines or indicators of how a system should be to make it RESTful. How you implement it is up to you. So developers across the world have come up with their own practices to go ahead and implement RESTful API services. But apart from that, we do not have a spec or standard to work against. And REST is all based upon resources. Here are a collection of resources, and do whatever you want with them. It is all about modeling your resources, talking about resources, getting a resource, acting upon a resource, like updating or deleting or creating resource. That is what REST comprises of. And what is a resource? A resource is anything that can have a representation: a computer, a fruit, a car, a person. All of that are resources. In our case, in our user data context, a user is our resource that we are dealing with today. And according to REST, every resource has a unique resource identifier, which is the first and basic and most important feature of REST. And when we are dealing with the resources, when client and server talks to each other, they are passing between them what is called a resource representation. And a resource representation is made up of data, like what you have see here. Then you have the hypermedia links that you see here, which comprises the heteros or hatios, and your metadata, your headers. This is actually resource representation. So your resource, which is held on the server, if the client wants to get access of the resource on the server actually sends back a representation of the resource on the server. And that helps the client change the application state, which is on the client. So that transfer of representation of resources, that is representational state transfer for you. That is how I understand REST, or that is how I understand the acronym REST as well. And REST is guided by 6 constraints, which are called Fielding constraints as well. So even though Roy Fielding believed that this is a nice kind of architectural style for the web, which runs on HTTP, he also believed that these 6 constraints can have or make any generic system RESTful as well. So he was talking about web, but with this 6 constraint in place, we can bring up something like an API to be a RESTful service or a RESTful system. So the first one is client server, which states that the client should ask for information and the server should provide that without any interruption. It should be stateless. So this is very, very different from the representational state that we spoke about. Representational state was about using resource representation to transfer the resource state from the server to the client. But this stateless or this statelessness means any session information should be stored on the client or the intermediaries. Any request from the client to the server should have all the information that the server needs to conduct and execute a call or whatever the client needs to do. It should not depend on any call that came before the request or any call that comes after the request from the client. Responses should be able to be marked as cacheable. Caching is not a constraint, but the ability to mark a response as cacheable is a constraint. So you can mark response as cacheable, and then it can be used to serve subsequent equivalent requests. The uniform interface, this is the most important of the REST constraint, and it is further guided by 4 different sub-constraints. The first one is identification of resources, which tells you that every resource must have a unique resource identifier, example, the URI you are dealing with. The manipulation of resources. REST does not tie itself to any format of a resource. It can be text, it can be HTML, it can be an image, it can be JSON, XML, whatever it needs, but you should be able to represent your resource in any different formats. You can also have self-descriptive messages, just like statelessness. your messages should be complete in themselves. And the final sub-constraint, which is Hatios, that actually completes REST in itself, hypermedia as the engine of application state. We will talk about that shortly, but Hatios simply means the browsability or the continuity which the server provides using hypermedia, which actually completes REST. And that is the most important of the REST constraint as well. You should have layered systems, or you should have the ability to have the layered systems, which means that the client does not need to know who it is talking to. It can be to a proxy in between, it can be to a gateway, or it can be to a service, the server directly. And your RESTful system can be made up of such layered systems. And you should be able to take away any other layer or add new layers, but the client to server communication should not break during this process. And each layered system must actually, or as a best practice, should actually do just one task, say like authentication or authorization, for example. So these are the 5 mandatory constraints. The last one is code on demand, which says that you can serve up code applets as well. And this is an optional constraint as well. But if you actually stick to all of these constraints and the sub-constraints, you will have a RESTful system in place. That was Roy Fielding's idea about REST. When it comes to REST, there are myths all over the place. Just because you serve up JSON or HTTP, that doesn't mean it is REST. I have been there, done that, but JSON over HTTP is not REST. REST doesn't talk about JSON. REST is built for web, which runs on HTTP. So we have RESTful APIs implemented over HTTP. But just because you serve up JSON over HTTP doesn't mean it is RESTful. Just because you invoke RESTful procedures over, say, over HTTP, that doesn't mean REST as well. What REST actually does is REST should be reusing HTTP using the constraints that we have in place. Finally, the biggest one is REST not equals HTTP. HTTP is a communication protocol, while REST is an architectural style which was put in place to generalize web, which runs on HTTP. So there are similarities between REST and HTTP. REST actually reuses HTTP. Because Roy Fielding was involved in HTTP as well as REST, you would find similarities. But because REST reuses HTTP, like the rich HTTP toolkit that HTTP provides with, like the headers, the caching, the URI, all of that, it is easier to implement a RESTful system or a RESTful API over HTTP, but REST is never equals HTTP. So we have RESTful systems reusing HTTP, and what we usually, or what ideally it should have, is a root entry point, which is like api.xyz.com. And once you get in there, you might have your users endpoint, you might have your places, you might have your locations endpoint. And then, just like a human would interact with the website, your API should be interactable as well. So forget the human interaction here. I'm clicking through mouse clicks here. A client, say a mobile app, should be able to get into your root entry point, and then using the hypermedia links that your server provides you with every response, it should be able to browse through your API. So imagine you browsing through a website. That is exactly how a client is supposed to interact with your REST API as well. But how does your API look like? What do you do? What you do is you have a single URI or a unique resource identifier, and you issue various HTTP verbs for over that URI. So starting with the user's endpoint, which is where I would have all my actions, all my methods to get, methods to read or create or update or delete my users, I would issue the get verb to read about a single user or a list of users. And of course, I need to make sure that the correct HTTP status code is served up as well. If I want to create a user, I would use post over the same /users endpoint. Of course, I would issue a request body, and what I would get is a 201 created with the URI of the newly created source in the location header. If I want to update a resource, I would issue the put command. You can also issue the patch, but then the request is different between put and patch. While put actually replaces the resource completely, patch is like incremental updates. You can also issue a delete HTTP verb over the URI, and of course, get the correct HTTP status code back as well. So this is how a CRUD operation would look like. But what if you want to get stories for your user? What if you want to get story comments? What if you want to get the latest activity? This is not how you would do that in REST. For that, you would have Hatios or REST Nirvana. So Hatio stands for hypermedia as the engine of application state. And this is what actually demarcates what we saw till now, which is merely an HTTP API, and makes it completely RESTful. So let us break this term down, hypermedia as the engine of application state. So we have a resource state stored on the server, say something about a user. Now, I, as a client, shouldn't be going and looking for what I need to do next, or I shouldn't be assuming as a client what I need to do with the user that I have in hand. It should be the server telling me what to do. So if I want to get the story of a particular user that he or she has uploaded today, what are the latest comments for a particular story that's been uploaded today, that is then worked out from the hypermedia that comes back from the server response. So the application state, what the client does next, that browsability factor is actually driven by the hypermedia that comes in from the server response. So your application state is completely driven by the hypermedia, which comes in from the server, which makes the server and client completely loosely coupled. That actually completes REST. And Hatios has been defined as the glory of REST in Richardson maturity model, which is a measure of how RESTful your system is. At level 0, we have the swamp of box, that is plain old XML. At level 1, we start thinking about resources, but we still use the HTTP post. Level 2 is where you have resources coupled with HTTP verbs as well as the status codes, which is what most of the APIs that we have out there today are. But level 3, when we have hypermedia controls, is when you have the glory of REST. This is when you have a complete RESTful system in place. And this is how the response from the server looks like. So I can get the information about the user ID 1, which is Harry Potter. From there, I can think about the stories of that particular user there. Once I click into that, or as a client, it would reveal more information about the comments, the latest activity that needs to be worked up from there, etc. So REST is meant to be chatty in place. If you think about a web page made up of links, a collection of such web pages making up a website, that is exactly how your RESTful API should be looking like. And this is a point of confusion as well amongst developers because for example, this is the expression that we had on our faces when I was talking about Hatios at a conference in the past with my friend Leila. Confusion. And that confusion arises because there is no, REST is not a standard or a spec by any means. It just defines some guidelines. Furthermore, there is no standard as such to specify or work with Hatios as well. Every person or every developer out there who is keen on implementing Hatios implements it in their own way. And as of now, we have a work in progress standard convention, which is HAL, which defines a set of conventions for expressing hypermedia links in XML or JSON. And application HAL XML or HAL JSON is the MIME type. There are various other MIME types in place as well, which can be used. So I think Leonard Richardson and Mike Amundsen, they wrote a book about RESTful web APIs, which is a highly, highly recommended read. I don't think that information can ever go out of relevance. It's a highly recommended read if you want to understand REST. Every time you read that book or chapters about the book, I have learned something new. Talking about the pros and cons, REST is supposed to be completely decoupled between the client and server, and it can be so if you implement Hatios, because the client is then dependent upon the server responses itself to work out what action to take next. This also means that API can evolve over time. API is capable, But regardless, there's seamless integration and reuse of HTTP. It is easy to consume, and it has got superior browser support. But having HATIOs in place, a completely RESTful system in place, means that your endpoint is very chatty. If I need to get to the latest activity of a user, I have to first go to the endpoint, then get the user, then from the user, go to all their stories. From all their stories, do some kind of working out to see what their latest activity is. So it can be really chatty. It can lead to overfetching. That is a lot of information being fetched and little used and the rest discarded. And because you don't have all the information coming into you at one go, it can lead to underfetching, which in turn leads to overfetching. It's a vicious circle, which also leads to N+1 problems. This also means that we have big fat payloads with REST. And finally, REST not being a single spec makes it all the more confusing as well. Every time I speak about this topic, it's the hardest for me to talk about REST because there's something new that I always needs to add. There's something I always discover. Plus, I always get the most interesting questions around REST as well because it's not a spec or a standard. But the chattiness and the overfetching and underfetching and the N+1 problems is the very reason why we have GraphQL today. GraphQL is very different from REST or gRPC in the sense that GraphQL is actually a query language for your APIs. And it is then supported by a runtime for fulfilling those queries. And GraphQL is actually a layer on top of your existing data. So your GraphQL can fetch your data from any database. It can fetch data from another GraphQL endpoint or even a REST endpoint. But all GraphQL does is it understands the queries that you ask for, and it understands that queries and parses and executes those queries and gives you the data that you ask for. At its simplest definition, GraphQL is all about specifying types and asking for specific fields on those types. We will come back to that point a little bit later. But what GraphQL gives you is a single but smart endpoint that takes in complex queries and builds the data output. So what it means is that I have my query here where I am asking for a course of an ID 1045. This query to me looks JSON-ish, and what I get back is JSON. And there are two things which is particular here. I only get what I asked for. There's ID, credits, title. The course might have a description. I'm not asking for that, so I'm not getting that. I'm asking for enrollments, which could be related data pertaining to this course. It could be somewhere else in the database. It could be in a different endpoint. But this single smart endpoint makes it easy for me to query not just information I want, also the related information that I want. So I can ask for student enrollments as well. And again, I am asked after only specific fields on the student, like first name, last name, and email address. So I get what I asked for, and that is it. And that's all what I get. The data that I get back is JSON. And the data is also a mirror image of the query. So which means that as a developer, the shape of the data that comes back to me is more predictable. And as you can see, it's the client who specifies what they are after, and what they get is data in the shape that they asked for. And server responds back with the exact same data graph as the query. And the reason why it is termed GraphQL is because GraphQL understands your data hierarchy and visualizes the relationship between your objects into a nice graph. And GraphQL helps you extract parts of that using your GraphQL queries, and that is why we have the name GraphQL in place. It's a very experience-driven, client-focused API, which means that your query, what the client issues as query, is the king or the star of the show here. You ask for the data that you want, you receive what you ask for in the shape that you ask for. So it's like a very smart person in between saying, hey, tell me what you want, where you want it from. I'll fetch that exact information for you and I'll make it happen. That is what GraphQL is all about. Talking about the features of GraphQL, it is strongly typed. It's got something called a schema at the heart of every GraphQL endpoint against which your queries are passed and validated so that your query is always right when it actually gets the point of execution on the server. GraphQL is a specification, so it's a standard, And we have implementation of GraphQL over various different programming languages. If you're thinking about .NET, GraphQL for .NET has been out there for some time. There's also Hot Chocolate, which is another GraphQL server out there. Both are really good. But GraphQL is a specification. All these implementations conform to that specification or the blueprint. GraphQL has a nice feature called introspection, which means it can query itself for information about the endpoint. So this has given rise to self-documenting tools and IDEs, which can help you get error validations. It can help you parse your queries, queries, even build up documentation from the endpoint without having a single line of YAML in place. That is fantastic, I would say. Your API is always fully documented. GraphQL is hierarchical. It understands and respects the relationship between your data and the hierarchy. What you get back from GraphQL is a JSON response that mirrors the query. GraphQL is an application layer. It doesn't concern itself with where the data is stored. It can be a database. It can be another RESTful endpoint. It can be another GraphQL endpoint as well. It is all about understanding the query and giving it the shape that you ask for. GraphQL is deemed version free because unless and until the client is after something which is not implemented yet, or a field is completely taken away, it is business as usual for the client. If you add something to the GraphQL endpoint, the client doesn't even get to know about it until they consume it. It's a very client-focused API. And finally, GraphQL is transport layer agnostic. GraphQL doesn't restrict itself to HTTP. I know there are implementations coming over WebSockets as well. I've seen issues and comments and discussions around it, but you can have GraphQL in any transport protocol, but HTTP again is the most common one. And talking about the system at the heart of any GraphQL endpoint, your GraphQL schema, this is your strongly typed system against which your queries are passed, validated, and then executed. And a schema is made up of types. The first one is your object types, which is a representation of your object. In our case, in our user data context, it is our user. So if you have stories, the story is again an object type. You have your comment is an object type. Your like can be a part of your object type, like a field or so. Then you have your operation types as well. So you have your object types and then the operation types starting with queries, which are the operation type for reading data. Then you have your mutations, which are your operation types for inserting, updating, or deleting data. And the last one, subscriptions, which is quite a standout feature of GraphQL again, which stands for pushed updates from the server. And all these makes up the different types. So your object types are types, as well as your operation types, query, mutation, and subscriptions. They are all types as well. So remember a few slides I spoke about having types and specifying fields. So every type, regardless of whether it's object type or the operation type, like query, mutation, subscription, they are all types, and types have fields. So if I think about my user object type, the ID, name, title, description, all that can be fields. And each field has a name that is used to identify the field in your queries. Each field has a scalar or complex type, which is the type of the field. And then each field is given meaning by the resolvers. The resolvers are the functions which converts fields into concrete data. So if you think about stories, it might have a picture, it might have some description, they all can be fields. Now, if you're thinking about queries, your operation types, you can have field to read data, you can have a field to read about just a particular user by itself. You might even have a random field to read about a random user as well. So that is also possible. So you decide how to act upon the data. And if it is all about reading data, they are all fields on the operation. If it is about adding a comment to a story or adding a like to a story or something like that, that can be fields on the mutations and so on. So be it operation types or object types, you have fields. And talking about our operation types, the query, This is one of the operation types in GraphQL and the top level entry point for read operations. Unlike REST, where you read using a GET HTTP verb, it usually happens over HTTP post in GraphQL because you are issuing flexible queries and you need to protect your server. This is at the bare basic minimum, but you can have something called persistent queries, which means you can have caching and then get your data across an HTTP GET. That is another point as well. You are issuing flexible queries. That's one of the reasons why we are using a post. Now, if you want to think about cacheability and things like that, you need to have GET in place, and persistent queries are a way to do that. And the keyword for issuing a query operation is the query keyword. And what you get back is a hierarchical JSON response that mirrors the query. And if you are thinking about a bare minimum GraphQL endpoint, you need to have your object types in place as well as the query in place as well. You can forget about mutations and subscriptions. It's not needed. And it is absolutely fine to have a GraphQL endpoint just with read operations. That's the bare minimum that you need alongside your object types. The next is mutations, where you change the data using inserts or updates or deletes. This is the top level entry point for write operations. Again, works over an HTTP post. The keyword is mutation, and it usually, every GraphQL mutation accepts an input type, which is a special type, as an argument. Now, the last one is subscriptions, which stands for pushed updates from the server. And unlike the client polling for regular updates, in this case, the server pushes back the updates to the client, and the clients can choose to listen if they want. It's not a must that a client should always sign up for a subscription. Subscriptions usually works over WebSockets and again uses HTTP post. The keyword here is subscription. And one most important thing about subscriptions is that they are stateful, because the client and server needs to have an understanding of who is listening to who and what fields that they are looking for as well, which makes subscription stateful. Now, what can be the fields on your query and your mutation types and your subscription types, which can then help you build up, or which can then help you visualize your endpoint? Your query can have a users field as well as a user field. Users to read all the information about all the users. User to read information about a particular user. You can have a create user, update user, and delete user field on your mutation operation type. And if you want to have pushed updates from the server when a user is added or a user is updated or a user is deleted, you can again have those fields in your subscription. So you have your type and you have your fields. And these are some of the queries that I have worked out. So this is for the users, getting all the users and some of the fields. This is to get a single user, and this is how you would have a variable and pass in some value using a variable. In this case, I would have the value of the ID sent in as a separate dictionary. You can have create user mutation. You can have an update user and a delete user mutation. You can even have subscriptions signed up from the client as well. Every time I add a user, the client would get the notification of a new user being added. So it's up to you how you want to define your fields in your operation types. And what if you want to read related information, like you want to get hold of the stories or the comments of a particular user? You can do that in a single query. So you can ask for nested information, related information, all of that in a single query. And this is one of the examples. Forget the squigglies, I haven't implemented this. So this is a screenshot taken from a browser-based IDE. And all these IDEs have schema introspection, which means that the minute they start up, they connect to the schema. And if you type in something, which is something that the schema doesn't implement, it gives you this squiggly straight away, which is an indication of the query being parsed and validated against your schema continuously. So this is a nice feature as well. But point here is that I can ask for related information in a single go. The client is in control over what they want to ask for here. And that takes us to the pros and cons, which is, first one is exact fetching. We only get what we ask for and nothing more and nothing less. We have a completely loosely coupled client and server with GraphQL. You have auto-generating API documentation. Your API is regarded as version free with GraphQL, which means none of the headaches with REST comes in with GraphQL on that front. But we have caching complexity. We need to be careful about file uploading. But I know that Hot Chocolate has tackled this, and there is a video on the YouTube channel on how to perform file uploading with GraphQL as well. You can have performance issues with complex queries, but again, then you can limit the amount of nesting that you can have with your queries, which would be then validated the minute you send something to your GraphQL endpoint. So the schema can validate that for you. GraphQL has a learning curve. Out of the 3 API paradigms, it took me the most of the time to understand even the basics of GraphQL, because GraphQL is that query language and then all about the types and the fields on those types. So once that slots in, it gets easier. But the learning curve is highest with GraphQL, and the community out there is also smaller with GraphQL, which means lesser people to ask things around as well. Now, talking about the comparison, which is the point of the day. The fundamental unit of REST is resources. With GraphQL, it is queries. And with gRPC, it is RPC or function or procedures. Coupling is the highest with gRPC compared to REST or GraphQL. Chattiness is highest in REST, followed by gRPC at medium and GraphQL at low. Caching, REST uses HTTP caching, while GraphQL and gRPC can be quite custom. Discoverability is the best, is really good with REST, provided you have the hypermedia links in place. With GraphQL, it is good owing to the introspective feature of GraphQL, while as with gRPC, you need something in black and white. Versioning, GraphQL is versionless, while REST and gRPC can require versioning, but gRPC has out-of-the-box techniques to support versioning, which means versioning a gRPC service is very, very easy compared to REST. REST is completely stateless. GraphQL query and mutation are stateless, while subscriptions are stateful. With gRPC, unary is stateless because it's just client and server. But when it gets to streaming, we are looking at stateful parts of HTTP2, which means that the streaming modes can be stateful. Talking about performance, gRPC and REST is good, while GraphQL can suffer in complex queries. The payload size can get very, very heavy with REST, while as it is medium and lightweight with GraphQL and gRPC respectively. Payload format is usually JSON or XML over REST APIs. With GraphQL, it is normally JSON. With gRPC, it's binary. Browser support is okay with REST and GraphQL, while as with gRPC, it is none. You need gRPC Web or gRPC JSON transcoding, which is a feature upcoming with .NET 7 as well, if you want browser support. As far as standards and specifications are concerned, REST is just best practices. It's not a standard or spec by any means, but GraphQL and gRPC has a formal specification. REST is very mature, but GraphQL and gRPC are still in early days compared to REST. Learning curve is medium with gRPC and REST, while it is the highest with GraphQL. Learning resources, there are many with REST, but with GraphQL and gRPC, there are fewer. Coming to .NET support, GraphQL only has third-party implementations, while as REST and gRPC is out of the box. Visual Studio and Rider templates, you are looking at external templates for GraphQL, while as with REST and gRPC, you have out-of-the-box templates. And coming to hosting on Azure, REST has superior hosting possibilities with app service, Azure Function, container services, all of that. GraphQL, again, with app service and Azure Functions, you can host in Azure. With gRPC, you need Kubernetes service or container service. You have Azure app service with Linux plans alone supporting gRPC. Windows is still a no-go. You need gRPC Web for that. And tools to test your endpoints, you have Swagger, you have Postman, you have your command line interfaces for REST. you also have nice extensions. You have VS Code extension, that is REST client, and the HTTP client, which is a JetBrains Rider extension. It's really, really useful. You have a file with .http extension, which you can then source control as well, which means your team gets the HTTP file, your team gets every endpoint that they need to test, and you do not need to leave your IDE to test your endpoint as well. You can test your endpoints from within your IDE, which is fantastic. With GraphQL, you have Graphical or GraphQL Playground, Insomnia, Banana Cake Pop. All these are IDs which can be used to test your GraphQL endpoint. Some of these can be even baked into your endpoint so that your developers can test your GraphQL endpoint on the browser. gRPC has gRPC curl and gRPC UI, which is a nice UI which is built on top of gRPC curl to test your endpoints. Again, gRPC UI can be baked into your endpoint, just like Swagger or OpenAPI or the Graphical or GraphQL Playground. Bloom RPC and Postman uses server reflection to understand about the gRPC endpoint first, and then you can test your API endpoints. I personally use gRPC UI when I build my endpoints. Use cases, that's a final point. REST is really good when you come to management APIs, that is CI/UD, when your focus is on objects or resources, when you have varied client usage, or for microservices. When I mean varied client usage, when you have browsers, when you have mobile apps, IoT devices, all of that, any device or anything that can issue an HTTP request can work with REST. With GraphQL, it is suited for mobile APIs, where you really need to think about your mobile devices, where your data is like a graph or it has relational data information. That is one use case of GraphQL. Again, if you have to fetch data from multiple sources, like a database, a REST API, and a GraphQL API, and putting all that data together and serving it over a single endpoint, like a gateway, GraphQL can help out there. With gRPC, if you have action-oriented APIs, internal services, microservices, IoT, and most importantly, polyglot environments, best suited for gRPC. If you have services which require high performance needs, again, gRPC can help. If you have point-to-point communication, like a REST API talking to another, it can be a gRPC service on the far end, while your REST API can be something which your browser-based applications talk to. If you're thinking of browser-based applications, never use gRPC because it still doesn't have the support it needs. Use REST or GraphQL instead. But if you have point-to-point communication, gRPC can massively help. And that's my resources for the day. And that is it from me today. So let me know if you have any questions. I can be out here answering some of the questions, and that's it from me.
That was an amazing talk, I will say.
Absolutely,
Thank
fantastic.
you.
Really good overview, and actually in the comments there's similar remarks being made, so that's really good.
Okay. What are
maybe
the...
in terms of... Yeah, go ahead.
So do you want me to answer some of the questions myself, or do you want to pick and choose?
We'll just ask you a couple, and we'll do them on stream.
Yeah.
So when you started talking, we did a quick poll with the audience on which API technology people are using between gRPC, GraphQL, and REST-like, and the result is quite surprising and unsurprising, I would say, at least for me. 80% of people are doing REST or REST-ish, followed by gRPC with 14%, and GraphQL is only at 4%. Is that what you see in the wild out there as well?
Yeah, absolutely. So when I was doing the research for my talk, this is exactly what I had as well, which is the reason I put that in the slides as well. The learning resources for REST or REST-ish are always the highest. We are looking at probably 20 years or 22 years of REST-ish APIs, while as with GraphQL, it is much newer in the market. We would say 2013, 2012, 2014, that is the time when GraphQL came into the picture. And I know from my personal experience that it took me a while to kind of float in that, okay, GraphQL is a query language. And if you look at GraphQL, you have your object types, which are types. Then you have your query and mutation subscriptions, which are your type. And what you do with your resources, how you act upon your objects, is what goes and makes the fields on those types. So it took a while for it to slot that in my head. Once that slots in, you get a better picture. But it took the highest amount of time to slot that in. RPC as such goes back way to 1970s and 80s. But thinking about gRPC in particular, that's something new out there. And I think, say, for example, gRPC JSON transcoding is something that other programming languages already have in place. But support for that in .NET is coming with .NET 7. So it is well supported, but we are still evolving that technology as we speak. And not having the browser support is something that goes against gRPC, I would say. But again, every API paradigm has a very niche use case as well for it is best suited for. So everything is out there for a reason.
Yeah. Yeah, I think the second poll we did, I love doing these polls today. It's something new I found on YouTube. The second one I did was asking if people are doing REST or REST-like, and it seems that maybe one or two persons answered with I'm doing full REST, and most of them are just doing REST-like. So that's also an interesting statistic there.
Absolutely. So most of the APIs that we do real world are in the level 2 of that Richardson maturity model. Level 2, you think about REST, you think about resources, and you use the HTTP verbs. That is where most of the real world APIs lie. You can even have that coupled with a level 0 thing. Like you might have a API endpoint which manages, say, your orders and carts. You might have your orders and your customers, all of that completely REST-ish, a level 2 with resources, CRUD. But then you can have something like add to basket. It could be like a controller action sitting somewhere, or clear the basket. It could be a controller action sitting there as well. So what I'm reading is that it could be a mixture of both as well. Again, it is how you see your resources, how you model your resources, which is what then goes with REST is not a standard or a spec. It is how you to do it. Should I use post or get? Should I use query string parameters, or should I use OData, which is more like filtering? Should I use post for upserts, or should I use a put for upserts? So all these interesting questions come out of REST. I think every time I've spoken about REST, there has been a good question which stands out.
Mm-hmm.
I think you can probably add versioning in the URL or in the headers as another discussion point there.
Yeah. How you want your resources to be manipulated. The accept headers. Would you have it over a query string URL, or would you have it as a header that you send in? That's one of the real world scenarios I've seen. Like when I'm playing with an API which I'm working, it has an XML as well as a JSON endpoint. So if you want to use the JSON, I specifically ask for JSON rather than issuing a header. That is also possible. So that's another point as well. But when I go back to the book that I read about RESTful Web APIs by Leonard Richardson and Mike Amundsen, he says to make use of that headers. And I think that is where the .NET community is more focused in going towards these days as well. Because if you go and look at the MS docs, there's clear examples on how you start with the APIs as well. So yeah, all sort of interesting information and discussions on REST.
Yeah, do you have any example tooling for .NET for REST? You mentioned the HAL format for JSON, but is there any tooling available? Do you know?
I don't think so. HAL is again a working progress standard. There is no known standard as such. And that is what even MS Docs tells me. There's no known standard for REST. So I tried implementing something for the first version of the talk that I gave in the past. It is confusing. It's objects, over nested objects, over objects. I get the idea, Hatios. Your server gives you the response which your client should be playing around with. But how many of us uses such clients, which goes to the root endpoints, figures out the users, then goes to the user, comments, fine, you know what, I'll just bake in my endpoint. I just want something which works. This can be way too chatty. That is where usually conversations go. Or Hatios is weird. It looks weird to have such hypermedia coming back in responses. Yes. When I read about Hatios for the first time, I'm like, this is weird. Why would I want this? You know, but again, we have Hatios for that decoupling that we need. That is why, and most of us don't implement that, which is the reason why most of the real world APIs are HTTP APIs, not completely RESTful APIs.
Your slides mentioned the N+1 problem with REST as well. So it's very easy to be able to have to make multiple requests to get a single chunk of data effectively, or some data that you want to work on in a single chunk. But is there a similar problem with GraphQL as well? You know, if you're going to be kind of requesting like a fairly complex object, is that going to have the same sort of performance problem that you'd get with a N+1 issue?
Not N+1, because GraphQL, for GraphQL, I don't need to issue N+1 request to get me the information. If I have a user, comments, and stories, all of these interconnected objects, I can query them at one go using a big query. But then what comes with the query is, with the amount of nesting that you can have, it can bring up performance issues because you're talking to a huge database somewhere underneath the hood. So it can give rise to potential performance issues. But then I know this for a fact that Facebook uses something called persisted queries. So the queries that you issue more often, that query itself is cached somewhere, and then an identifier associated with that query. And every time you want to get information using that query, you fetch that identifier, reuse that issue, reuse that query, and get the information back. So there is a bit of caching going on, which you can make happen. I think the term to Google is persisted queries. So there are ways to overcome that. Again, you can limit the amount of nesting that you have in a query as well. And your schema would pick it straight away for you because of the validations that I've got in place as well. So as a developer, if I'm using the GraphQL Playground or one of those IDs to test my query, the minute I write something, squigglies appear, I get every instance, and I get the error alerting that I need to tell me that, hey, you cannot go with this nesting level. That is possible in GraphQL as well.
Cool. Yeah, maybe quick related question there, and this will definitely show my age. I think of GraphQL a little bit as a successor to OData. And I know in OData, a lot of people were just exposing their database or exposing their iQueryable to the internet, and people could just query pretty much anything. You already mentioned that you can limit the amount of nesting and things like that, but are there ways to also limit what people can do on the data store you have in the background?
Yes, if you're thinking about, say, for example, this is one question I get asked quite often as well at conferences when I speak about this topic. Can you implement authentication on certain fields alone? That is possible. If you look at the GitHub API, GraphQL API for GitHub, there are fields which you can query without being authenticated. But then you can introduce authentication and authorization on certain fields alone. So that is possible as well. So you can have that. You can limit what users see. I don't know specifically about limiting what users can do because this is a client-specific API. The clients are in control, but you can have things like this. Say, for example, you want to mark a field as authenticated. Fine, that is fine. And I am pretty sure I've seen something else as well on the similar line. Can't remember what, because I was reading on there could be potential ways to versioning things, and what GitHub has done is not versioning, if you understand what I mean, limiting things to certain uses alone. You can have field-specific directives again to make sure that they execute only when something's happened. That is possible. So a lot of things are possible with GraphQL, I would say. Yeah.
Cool. All right. I think we can wrap up. There's a couple of really interesting comments in the chat as well, so make sure to check those afterwards. But I guess we are ready to let you go. Again, thank you for a fantastic session and a great comparison between all of the different API technologies that are there.
Absolutely. Thank you very much.
I guess we'll see you next time.
Yes, of course. Thank you once again for everyone who was on my talk. And thank you, Martin and Matt, for hosting me. I had fun presenting and I had a very good discussion as well.
Cool. Thanks for joining us today.
Thank you.
Bye.